Something super wild is happening on the moon. For about 15 years now, ever since a Japanese probe first caught a glimpse, scientists have found over 200 of these super deep, super mysterious holes all over the lunar surface. It's like the moon is a giant block of Swiss cheese, and these holes are the biggest, most intriguing holes you've ever seen. What's super cool and a little bit eerie about these craters is that they're not just random structures. Many folks are wondering if these could be secret entrances, maybe even leading to underground caves or tunnels. These could be the ultimate secret passageways to understanding what the moon is really all about. And who knows, maybe these hidden depths hold the answers to humanity's grand adventure among the stars. It's like a cosmic treasure hunt, and these enigmatic holes are the first big clues. China is rapidly becoming a leader in lunar science through its Chang'e program. Their recent discoveries are significantly advancing our understanding of the moon's history and resources, highlighting China's growing influence in space exploration. China's lunar program, Chang'e, has advanced through distinct phases. Initial orbital missions, Chang'e 1, 2007, and Chang'e 2, 2010, successfully mapped the lunar surface and gathered crucial preliminary data. Phase 2 marked a significant leap with soft landings. Chang'e 3, 2013, achieved China's first lunar landing and deployed the U2 rover, a feat not seen in nearly 4 decades. This was followed by the unprecedented Chang'e 4, 2019 mission, which successfully landed on the far side of the moon, a previously unexplored area due to communication challenges. Despite occasional setbacks, such as the uncontrolled re-entry of Long March 5B rocket debris in May 2021, China has rapidly emerged as a major player in space exploration, with taikonauts actively working on the Tiangong space station. The most recent and scientifically impactful missions, Tiange 5 and Tiange 6, have focused on lunar sample return, directly addressing critical knowledge gaps in lunar geology. Looking ahead, China's manned space agency announced in May 2023 plans for a manned lunar landing by 2030, aiming to establish a permanent human presence on the moon. The discoveries from the Chang'e 5 and Chang'e 6 missions, along with the fascinating lunar pits found recently, are considered the most significant or shocking in decades. The Chang'e 5 mission successfully retrieved approximately 1.731 kilograms of lunar samples from Oceanus Procellarum, a previously unsampled region of the moon. Analysis of these samples yielded 2 significant findings. Firstly, the basaltic rocks were dated to approximately 2.0 billion years old, indicating much younger volcanic activity than samples from Apollo and Luna missions, which were generally over 3 billion years old. This discovery challenges prior assumptions about the cessation of lunar volcanism, suggesting the moon remained geologically active for a longer period and necessitating a re-evaluation of lunar thermal evolution models. Secondly, direct evidence of water, in the form of hydroxyl, was found within the lunar soil and apatite minerals. While previous orbital missions had inferred the presence of water ice, Chang'e 5 provided the first direct measurement from returned samples, confirming its in-situ existence and offering crucial data on its abundance and distribution, with profound implications for future resource utilization. Building on past achievements, the Chang'e 6 mission targeted the Apollo crater within the South Pole Aitken Basin, the moon's most ancient and largest impact basin. The mission's goal was to collect samples from the moon's far side, a region recognized for its distinct geological composition and history. The successful retrieval of these samples marks an unparalleled accomplishment, providing the very first direct access to material from this enigmatic lunar hemisphere. Initial analyses are expected to unveil insights into the moon's deep crust and potentially its upper mantle, offering an unprecedented look at the moon's internal structure and early differentiation. This is due to the immense impact that created the basin. These lunar samples are of paramount importance for unraveling the mysteries surrounding the moon's fundamental asymmetry. Scientists are particularly keen to understand why the far side of the moon possesses a significantly thicker crust and lacks the extensive, dark plains of solidified lava, known as maria, that are so prevalent on the near side. Analyzing the composition, isotopic ratios, and chronological data from these samples will provide crucial insights into the early differentiation and evolutionary processes that shaped the moon into the celestial body we observe today. The stark differences between the two hemispheres offer a unique window into the forces and events that governed its geological history, potentially revealing secrets about large-scale impacts, internal convection, and even the interaction with Earth in the early solar system. This will help constrain models of lunar formation and evolution. Additionally, while Chang'e 6 did not directly sample the permanently shadowed regions thought to contain significant amounts of water ice, the returned regolith may hold volatiles that can illuminate the origin and distribution of lunar water, contributing to further water ice characterization. Beyond the sample returns, a significant focus of current and future lunar exploration revolves around the strange dark holes identified on the moon's surface. Scientists believe these pits are collapsed sections of ancient lava tubes. Billions of years ago, the moon was geologically active, with volcanic eruptions creating rivers of molten lava. As the outer layers of these lava rivers cooled and solidified, they formed a crust, while the molten lava beneath continued to flow, carving out vast underground channels. When volcanic activity subsided and the lava drained, these hollowed tunnels, known as lava tubes, remained. On Earth, lava tubes like Hawaii's Kazumura Cave can stretch over 40 miles, 65 kilometers. However, due to the moon's weaker gravity, approximately 1/6 of Earth's, these lunar tubes can grow to much larger sizes, spanning more than a kilometer wide. Over time, some sections of these tubes collapsed, creating the deep holes visible on the surface today, while the rest of the tunnel remains intact, hidden beneath. These holes are essentially access points to vast underground worlds preserved for billions of years. The discovery and confirmation of extensive hollow tunnels beneath the lunar surface represent a significant breakthrough in lunar science and a potential game-changer for future space exploration. Initial clues to their existence came from high-resolution imagery, which clearly showed tunnels branching off from the bottom of several prominent pits. These intriguing features were particularly evident in Mare Tranquillitatis, a large lunar mare on the moon's near side, and within the Marius Hills, a volcanic complex that hosts numerous rills and domes. Further compelling evidence emerged from the Selene Kaguya orbiter, a Japanese lunar probe. During its mission, Selene detected a highly distinctive echo pattern emanating from the Marius Hills skylight. This echo pattern was so unusual that it strongly suggested the presence of a vast, uncollapsed underground cavity directly beneath the surface. This initial observation strongly suggested that these pits were not merely isolated depressions, but rather served as entry points to a far more extensive subterranean network. Building upon these initial findings, NASA's Gravity Recovery and Interior Laboratory (GRAIL) mission provided the definitive confirmation. The GRAIL spacecraft, a pair of identical satellites orbiting the Moon, meticulously mapped the Moon's gravitational field with unprecedented precision. Areas with less mass, such as large underground voids, would exhibit a subtle but measurable decrease in the gravitational pull. By carefully overlapping the echo patterns detected by Selene with the detailed gravity field data from GRAIL, scientists were able to conclusively confirm the existence of these expansive hollow spaces beneath the lunar surface. Researchers utilized this comprehensive data to confirm the presence of these subterranean structures. They were also able to precisely estimate their depth, size, and potential extent, uncovering tunnel networks that could span kilometers. These subterranean formations, likely ancient lava tubes, offer a tantalizing prospect for future human settlements, providing natural shielding from harmful radiation, micrometeorites, and extreme temperature fluctuations on the lunar surface. These discoveries hold immense scientific significance. The evidence of recent volcanism on the Moon forces a revision of lunar thermal models, suggesting a more complex and prolonged geological activity than previously understood, impacting our comprehension of how terrestrial planets evolve and cool. The direct detection of water in lunar samples from both the near and far sides substantiates the hypothesis that water is a ubiquitous lunar resource. This is a game changer for future lunar initiatives, as water can be processed into breathable oxygen, rocket fuel, hydrogen and oxygen, and potable water, drastically reducing the economic and logistical challenges of maintaining a continuous human presence on the Moon. The true potential of the lunar pits and lava tubes extends far beyond scientific curiosity. The Moon's surface is an unforgiving and dangerous environment, constantly bombarded by cosmic radiation and micrometeorites, with unpredictable solar storms posing lethal radiation risks. Temperatures fluctuate drastically from 250 degrees Fahrenheit during the day to a bone-chilling -200 degrees Fahrenheit at night. Lava tubes offer a natural shelter from these dangers. Inside these tubes, the thick basalt walls and ceilings would protect astronauts from harmful cosmic radiation, deflect meteoroid impacts, and provide a stable internal temperature. Data from the Lunar Radiometer experiment, part of NASA's Lunar Reconnaissance Orbiter (LRO), is designed to globally map the Moon's surface temperature and thermal properties, shows that the temperature inside the Tranquility skylight remains a stable 63 degrees Fahrenheit or 17 degrees Celsius. These ready-made bunkers could serve as the foundation for permanent lunar colonies, saving the immense effort of building protective structures from scratch. Their enormous size means they could potentially house entire city blocks, complete with living quarters, research labs, and manufacturing facilities, all safely tucked away from surface hazards. The confirmation of accessible water resources and the protective capabilities of lava tubes transform the Moon from a mere scientific outpost into a potential staging ground for deeper space exploration. The prospect of in situ resource utilization, or ISRU, becomes increasingly viable, enabling the establishment of self-sustaining lunar bases.
So in situ resource utilization, or ISRU, means using resources that aren't from Earth in order to carry out different missions. And so ISRU is important for a number of different reasons. One of the ones that we think about most is cost. And so when you think about taking a pound of, for example, oxygen or other things that astronauts might need off of the Earth, that's going to cost thousands of dollars. And so if we can produce those resources where they're going to be needed, such as on the Moon or on Mars,
These bases could serve as research laboratories, observatories, or even refueling stations for missions to Mars and beyond. China's explicit long-term goal of establishing an International Lunar Research Station, ILRS, by the 2030s is directly supported by these discoveries, positioning it as a leader in future lunar infrastructure development. The stable environment within lava tubes could also facilitate the growth of food through hydroponic systems or other advanced agricultural techniques, making long-term presence on the moon not only feasible, but far more affordable and practical by reducing reliance on constant resupply missions from Earth. The idea of pressurizing these underground spaces to an Earth-like atmosphere, using the 30 to 50-foot thick basalt roofs as natural protection, could create breathable habitats, significantly reducing the weight, complexity, and shielding needed for surface habitats. Before establishing lunar cities in lava tubes, critical challenges remain, primarily assessing their structural safety and stability. Space agencies are developing cutting-edge technologies for this purpose. NASA's Jet Propulsion Laboratory is working on the Dune Axle rover, designed to split into two parts, with one anchoring at the surface while the other descends into a pit, mapping the interior with cameras and laser scanners. The University of Würzburg has developed Daedalus, a small spherical robot that rolls through tubes using LiDAR to create detailed 3D maps. Perhaps most innovatively, a team at ETH Zurich in Switzerland has developed Space Hopper, a robot designed to hop across the moon's surface and into craters and pits, efficiently capturing visual data and exiting. China also has similar plans, aiming to use mobile, partially tethered robots with 3D imaging and navigation systems to map and investigate these underground spaces. The data collected by these robots will be crucial for determining if these caves are structurally sound enough to house human settlements and withstand potential moonquakes. Beyond geological insights, these caves may hold valuable resources. Helium-3, a rare isotope found in lunar rock, could fuel nuclear fusion reactors, offering nearly limitless energy. The potential to find significant quantities of water ice within these tubes could provide oxygen for breathing and hydrogen for rocket fuel, further reducing reliance on Earth for supplies and turning the moon into a launch pad for venturing deeper into the solar system. China's lunar achievements are not merely scientific milestones, they are also significant geopolitical statements. The successful sample returns, the pioneering far-side landing, and the ambitious manned lunar landing target for 2030 underscore China's rapid advancement in space technology, challenging the traditional dominance of the United States and Russia. This has intensified what many observers term a new space race, particularly between the US through its Artemis program and China. While both nations express a desire for peaceful exploration, the competitive dynamic is undeniable. China's independent capabilities and its willingness to collaborate with other nations, e.g. Russia, European Space Agency, on its ILRS initiative, are reshaping the landscape of international space cooperation and competition. The ability to access and utilize lunar resources will be a critical factor in determining future leadership in space. This new race is different from the 1960s, with private companies like SpaceX and Blue Origin joining, focusing on driving down launch costs with reusable rockets and building a lunar economy through mining lunar materials. China, with its state-backed resources, is playing a long game, mobilizing immense government funding and long-term planning, aiming for a permanent presence on the moon by 2030 and securing dominance not just in space, but geopolitically. China's ongoing lunar missions, such as Chang'e 5 and the upcoming Chang'e 6, are revolutionizing our comprehension of the moon. These missions have uncovered volcanic rocks, water, and lava tubes, laying the groundwork for human expansion beyond Earth. China has emerged as a dominant force in space exploration, having successfully retrieved samples, explored the moon's far side, and conducted subsurface studies. This leadership in lunar exploration and resource development positions China to significantly influence humanity's future in space. Lunar caves may serve as humanity's next sanctuary, much like ancient human refuges. These caves could be crucial for our ability to thrive throughout the solar system. China's deep Earth drilling endeavors, alongside its lunar exploration efforts, underscore its position as a global leader in scientific and technological advancement. We're talking about progress here.